Hi, welcome to this video. I'm gonna show you how to make these two different systems. This one on the left makes this kind of like pixel sorting effect, and this one on the right more like Datamosh or like glitchy. And both of them work on the same principle, which is to transform an image instead of a feedback by exact pixel amounts. So you keep that detail. We're gonna go over what that means in a sec. If you just wanna copy and paste entire project, I'm gonna have it on my Patreon. So we can start now. I'm gonna delete everything and start with a constant over here to set up my resolution in X and Y with 1080 by 1080, and let's get a movie file in. We can make it the size of our resolution, and this, I think the effect works better when the image isn't like solid like this. So I'm gonna add a noise here with a threshold, and I can multiply this around. Let's make this like that. Okay, let's start with the first one. I'm gonna start with a null here, and our feedback that's gonna go into a transform, and with an under, so that we're always adding this image or whatever input we have on top of our feedback, and drag it to a feedback. And now if I turn the translate up a little, you can see it's moving. Okay, now you can see that as the feedback goes on, the image gets blurrier and blurrier, right? You can see right here in the middle is pretty sharp, and then it gets really blurry. That's because since these values right here that we're translating with aren't, uh, they don't divide our resolution perfectly into an integer amount, it makes it so that when this transformation gets made, it has to perform a little bit of interpolation, and that over time causes more and more interpolation. It ends up getting blurry, as you can see. So how do we deal with that? First off, well, Touch has this option right here to change this from fraction to pixels. As you can see, this wasn't a perfect integer amount. If we change that, now it is, so you can see it remains sharp all the way to the top. That's great. Okay, we can also, there's this input smoothness option over here, and if we change that to nearest, even if this isn't exact now, it still remains sharp because we can just turn off the interpolation, right? It was interpolate pixels and now it's nearest. Okay, let's leave that like that for now, and we'll see. Okay, so now instead of controlling this with my mouse, I'm gonna control this with a chop. I'm gonna use an LFO, and this is gonna be my tx, and let's use for the y a constant. You can merge those. And let's try this. Okay, and I use tx for tx, dy for dy. Oh, look at that. I'm gonna turn down the frequency a little. Now, there's something weird going on. This is like a smooth up and down using a sine wave, but our feedback here isn't really smooth. It's these kind of jagged or geometric straight lines, and that is happening because this number right here is a float value, but because of all the things we did here, this can only move in integer value of pixel, in exact value of pixels. So every time it takes one of these decimal values, it's gonna round it to its closest integer, and that's gonna create a little bit of a rounding error, right? Because there's a difference between the actual value that it should be moving it by and the value that it's moving it by, that is going to be rounded. And remember, if we change this to interpolate again, you can see it gets blurry. It gets smooth again, but it gets blurry, and we don't want that, right? So how do we deal with that? We need to actually do the rounding by ourselves, so we can take into account that rounding error and keep adding it to the next frame so that it gets taken into account for the movement on this transform. Okay, so how do we do that? Okay, so we need to basically take this floating number and turn it into an integer and keep the floating part, right? So we need to divide this for the integer part and the floating part. Okay, so now we're going to use a feedback for this to keep track of our values. And it is a feedback. I'm going to add, I keep adding. You can think of this as like a velocity or like a speed. And I keep adding the new values to our feedback. Here, add, and now this is a value that we need to round and to keep the integer part and to keep the floating part, right? So now, to do that, if I use a math here, you can see there's an integer option, but it turns out that none of these options work for us, because what we want to do is not floor or seal or round necessarily. We want to round towards 0. What does that mean, right? We need to, if it's negative, we actually want to ceiling, and if it's positive, we want to floor. So if it's negative, we want to, for example, here it will be 0, right? Because we want the integer part only, so it's 0. Here it will be 1. If it's positive, we want to floor, so here we will get 1. So instead of using any of these, we actually need to do a little more work. So I'm going to use this math to get the positive of this original one. And I'm also going to use a function to keep the sign. So now I can use here a limit, quantization. Here we have the same options, but now we can floor because this is positive, floor to 1, and we can multiply it back with its sign. Right here, multiply. There we go. This is our integer value. As you can see, this value is always the integer part of this one. And to get the rational part of this one, actually, to get the rational part, we just subtract the original value. We subtract the integer part from the original value. So it's another math like this, and combine chop, subtract, and there you go. And this is what's gonna go back into our feedback. This is the rounding error, that we need to keep for the next frame, right? So this goes into our feedback right there. This looks really bad, so I'm gonna use a select right there. And there we go. I'm gonna add a keyboard in to reset these feedbacks when I need it. And now, okay, now we can use this or integer part. I'm gonna call it integer. I'm gonna color it different. Let's use these values instead of these ones to control transform. Let's see what happens. There it is. It works perfectly. Now it's moving smoothly, and also it's not getting blurry because we're always moving by an exact pixel amount. This is always an integer right there. So this is the first system. You can play with different parts of this network. You can change, for example, the LFO. If you change the type of ramp here, for example, for a square, you get a different shape. You can play around with the frequency, with the amplitude. Let's say here I use a different LFO for dy. Here I use a Gaussian, for example. You get something very different, right? I turn it back to its original. You can also change here on the transform, the tiling. Instead of 0, you can use repeat, and it's gonna come back around. This can also be cool. Something really interesting, that because we just had a limit here to round instead of a math, I can change this value, and as long as it's an integer, it's gonna keep working, right? So if I say instead of 1, 2, now it's not, it's moving 2 at a time, or rather the error, it gets accumulated until it gets big enough to move the image by 2 pixels, right? In this case, if I increase even more, you get this, right? This is still running real time. It just looks really jagged, which I think can also be something to do. Also, this under, because I use an under here, you can bypass it, and now the original image doesn't get added again. So you get this continuously moving thing. Remember, you can turn this back down and bypass it again. Okay, cool. That was the first one. This is like pixel sorting. Now let's do the second one. The second one works the same way, but instead of using a chop to control our movement, we're going to use tops, and that's going to allow us to do even more things. So basically, I'm going to recreate the exact same thing, but using tops for this feedback. So I can copy and paste this now here, and now I'm gonna basically do the same thing. So for our input, I'm going to use a constant, and this constant has to be the same size, and for it to be RG, and for its value I'm going to use the same one as I use right here, just to keep track that we're doing the same thing. So if it has the same input, it should be the same, right? And this is going to go into a null. And again, these are feedback. That's our feedback. This is our feedback. And we're going to keep adding these new values. Then now this is the thing that we need to round, and again we use this method with a math that is going to turn this positive, and a function that we're gonna give the sign, and now if it is positive we can floor it again with a limit, floor 1, and multiply it again with its sign. There you go. Again, these are integer. Gonna color it to remember, and to get the fractional part we just subtract that integer from the original one, the original value. There it is, and this is what gets sent back to our feedback right there. Also, this feedback should also be controlled by this keyboard. And there it is. Seems to be working. Let's again use our integer. Now we're not going to use a transform. We're going to use a displace, because we're not using a single value to move the image, and we're using a whole texture. So this goes into displace. It looks again kind of bad, so I'm going to use a select right there. And now it's kind of not working, because we need to change a lot about this display. So first, vertical source should be set to green, because we're using red and green. The midpoint is going to be 0. And now the displace weight. So how big should this be? Right? This is in fraction, right? Like the transform originally was. So when this is 1, when the value in this image is 1, this texture, we want the displace to displace the image by a pixel. So how do we get the amount of, the fraction of the image that is a pixel? You just divide 1 by our resolution, right? So 1 divided by res x, and y divided by res y, right? So this tiny amount right here is how much a pixel is in terms of a fraction of the entire image. I hope that's clear. So now something is happening. Let's look at this one and look at this one, because this should be the same, because we're taking the same input. And we see, okay, it's going the opposite way. Let's also turn on the tile. Okay, so on this space we actually have to multiply this by -1 on both axes. Okay, it's going the other way. Also, this display has the same tiling here. This here is called extend. I'm going to also turn it to 0. You can see this is like way longer and this is shorter, because as it turns out, because of the way displace works, you actually need to multiply this by 0.5 again. So instead of -1, you want to multiply by -0.5. And now, there it is. As you can see, they are the same, they are identical, except that this one was working with chops and this one is working with tops, but even though they are different, they are giving the same output. Isn't that cool? Okay, but now the interesting part about this is that this doesn't need to be a constant, right? We can plug any texture here as input. I'm gonna get a noise that has to be the same resolution. And again, let's be RG. I'm gonna turn off monochrome, it should be offset to 0, and let's see. Whoa, oh, the wrong one. Look at that. Isn't that weird? And as you can see, even though there's all of this movement, we're still not losing that detail, right? It's not getting blurry. It's always sharp. Let me animate this with apps time seconds, not seconds. Look at that. You can even change the offset here. It goes on one side. And again, you have all of those options that you had with the previous one, right? You can, in this display, change the extent to repeat, and now it's wrapping around. You can also play around with this limit. This value right here doesn't have to be 1, right? As long as it's an integer, it's gonna keep working and keep that sharpness, right? So if I say to 5, you get this glitchy effect. Also, if I change this input, for example, with a limit and quantize not the value but the position, now it's a grid. Now reset it, and look at that. I think I'm going to increase here the amplitude so it moves faster. Look at that, pretty cool, right? Yeah, you can play around with the limit size here, maybe 10, and you get what I had at the beginning. You can also bypass this under again, and now the original image doesn't get put on top anymore, and you get just kind of this amorphous shape moving around. And that's it. That's the second one. Okay, I hope this was pretty useful. And again, if you just want to copy and paste this, I'm gonna have it on my Patreon. I'll really appreciate your support there. And also, if you make anything with this, please tag me or send it to me. I would love to see it. So yeah. Okay, I hope you liked it. Bye.